Recall when we were discussing dedicated equipment, the FDA guide clearly said visibly clean is enough. Formal validation of the cleaning process is not necessary. Fair enough. Later, when we were setting limits, they said there is a chemical determination which is on the basis of dose-based calculations, whether it is therapeutic dose or toxicological data or a maximum concentration like 10 ppm or whatever. They also said there is microbial determination and mentioned a physical determination where it was critically mentioned visual inspection. We see that the EU GGMP and Canada say do the dose-based calculations, do the 10 ppm based calculation and inspect visually, and whichever is the lowest, that is what will apply, the most stringent of the three. And the same sentiments were echoed by the paper from USA, where the authors talk about not 10 ppm but dose-based calculation as well as visual inspection. How can you compare something that is visual, that is a qualitative estimation, with something that is quantitative? So let's try and understand what do they really want us to do. Visual inspection is a manual process and therefore subject to variability. There are some of us, in fact most of us, we look but we don't see. There are some who both look and see and observe. For example, when proofreading manuscripts, all of us are not qualified to be proofreaders. There are those whose eyes spot errors. They are very quick at it. We need such people as inspectors, visual inspectors. I talked first about a qualification process for assembling the cleaning crew. I talked about a qualification process for the swabbing crew. Now let us discuss how do we go around qualifying the visual inspectors. A medical test for checking their vision is certainly important, but that's not the only thing. As I said, many of us know how to look, but we don't always see. We have to find those people who got that eye for detail, that passion for noticing things, and get them together. Let's say we get around 15 people together. You first establish through dose-based calculations as to what is the acceptable residue that can be carried over. There's no excuse for that. You have to do your calculations. You may also like to do the maximum concentration carryover as 10 ppm or 50 ppm or whatever is the level that you've chosen. Most people work at 10 ppm because at 10 ppm, even poisons do not have any noticeable toxic effect. So if poisons are not going to hurt, and if the heavy metals which are restricted to 10 ppm, they are not going to damage you. What we are really trying to do is any residue, known or unknown, is as to be treated on par with the poison. So not more than 10 ppm. That's the general logic. So whatever, on that basis we find out what is the kind of residue concentration that is permitted. Let us say on the basis of our calculations we find 10 micrograms per centimeter square is the kind of limit that we have arrived at. Now, how do we know who can see 10 micrograms and who can't see 10 micrograms? So this group you have got together are given under lighting conditions very similar to where they will be inspecting. They are given coupons where you spike it initially with 30 micrograms per centimeter square. Out of the 15, 3 of them can't see it at 30 micrograms, so they move out. You're left with a group of 12. Reduce it from 30 to 25, then to 20, then to 15, and then to 10. And see how many of the original 15 still remain. To make sure that somebody is not bluffing or somebody is not guessing, you show 20 micrograms, show 15 micrograms, and again repeat with 18 micrograms. Now, if the person said he could see 15 micrograms and said, sorry, I can't see 18 micrograms, or you show him 10 micrograms, he says he can see it, you show him 12 micrograms and he says he can't see it. These are giveaways by which you eliminate these unreliable inspectors. You are left with, let us say, a group of 5 people who are able to consistently see at residue level at 10 micrograms per centimeter square. Do you stop there? No. You reduce it to 9 micrograms. Out of 5 people, 1 falls off. You reduce it to 8 micrograms. You reduce it to 7 micrograms per centimeter square. Another person falls off. So now you're left with 3 people who can reliably see down to 7 micrograms. You reduce it to 6 micrograms. 1 more person falls off. You're left with 2. You reduce it to 5 micrograms. 1 more person goes off. Now you're left with only 1. You reduce it to 4 micrograms. The person can see it. You go down to 3 micrograms, the person can't see it. You repeat with 5 micrograms and he can see it. You repeat again with 4 micrograms and he can see it. So here is a person you have who can see down to 4 micrograms per centimeter square. You have 2 people who can see down to 7 micrograms. You have 3 people down to 8 micrograms. Now these people, if they inspect a surface and then say that it is clean, that means it is clean. It is below 10 micrograms per centimeter square, which is your limit. This is how you are expected to qualify your inspectors for visual inspection, and every 3 months you should have a protocol by which you re-qualify them to ensure that they continue to be consistent and continue to be reliable. So now you have identified your inspectors. Now, are there any issues? Yes, if they are supposed to be inspectors who are visually examining, whatever they are trying to examine should be visible. Now, here are some issues that may require more than just visual inspection. Let's have a look. Here are possible things to consider that might indicate the need for more than just visual examination. First, are the worst case, hardest to clean locations accessible for visual examination? If not, one should consider other means of evaluation, such as rim sampling. Second is there documented evidence or concerns about buildup of microbial residues? If so, one should consider microbial sampling as part of the cleaning assessment. Next, is there documented evidence or concern about buildup of unacceptable degradation products, which could be present at objectionable levels but still not be visible to the naked eye? If so, one should consider sampling for these degradation products. If any of these concerns are documented and valid, then it makes sense to consider a formal cleaning validation protocol to demonstrate that the cleaning procedure is as good as it is expected to be. I sincerely hope I've been able to clarify on this word visually clean.